Time for some of the remanufacturing on this transmission. So it is a 40-year-old transmission roughly. It's going to have stuff that's worn out. The parts aren't necessarily available, nor is finding good cores necessarily easy. So one of the challenges that I mentioned on this transmission that I want to solve is some of the slop between this front and back half of this drum. And your direct, so third gear, and low or first gear basically sit inside of here, along with the planetary for first gear. So basically, the dilemma, kind of what you got to work through, is that in the housing, these tabs on this drum lock into here. And as you get more and more wear, we've got like a 19 thousandths inch feeler gauge here, and that allows the back half and the front half of the drum to move. But it isn't so much relative to each other that it allows it, it's that it allows it to do this. And that ends up basically acting like a jump rope when it's spinning fast because it's not super locked in. Additionally, this is a nice flat drum. So I can reuse it, so it's worth welding onto that. I also mentioned that if this was an early version, the back half of that. The back half of this one, since it's an 84 up transmission, is already hardened. You can tell because that's the way it is. Basically, when you turn this shaft, there's really no wear between this shaft and the female spline on this, and the teeth on this aren't worn. It's the receiving pocket on this that's worn. But this, it's flat, and I checked that by using, well, a set of parallels, since this is about as straight as anything you're gonna get. And laying it on, and you can see you don't see any light in between. So that's nice and straight, so you're okay. The other dilemma is that back landing there is third gear apply, and this middle landing here is reverse apply. That female pilot fits on here, and basically from the valve body, you've got your overdrive apply, your reverse apply, and your third gear supply that feeds through this part. So what happens is, because this is worn, allows it to move up and down like a jump rope, it eats that bushing worse than it should. And that bushing sits on that race, and when it moves, it allows this iron sealing ring to wear into there. This is a common problem. Some people, I think it's out of a Toyota or something, sealing ring that's just slightly larger, and then they'll actually ream that out. If you dual feed the transmission, so if you're familiar with the Turbo 400 stuff, you basically pull out the sealing ring between reverse apply and forward, and then feed more piston area. I'm not doing this on this transmission. From my understanding, my drum, I went with the Art Car hardened drum. If you do dual feed, that's gonna clamp third very firmly, and the likelihood of snapping the shaft on that is higher if you dual feed. So because I save money there, I don't have the power, I'm not super concerned, I'm not dual feeding, so I'm keeping all the sealing rings as factory. But I will need to brake hone that, or like, you know, those cylinder hones with the 3 pads, just to clean that up. So I'm gonna get this chucked up in the lathe. Actually, I'm probably gonna weld just some very light beads there, grind it smooth, and get this fitting very snug into here. Then I'll move this over to the lathe, polish that up with some 240. So catch you in about 2 minutes. Drum remanufacturing station. I just shoved a glove actually in here to make sure that there's no slag that gets in here, causing issues. Set up my welder, clamp it in my vise, just put a small bead weld in there, and then use my grinder and file and build up that surface. So if you remember from the earlier set in the video, it looked kind of like a stair step where the far back, that distance here, there was very little tolerance or kind of distance between the male ears on the rear half of that drum and the female slot on this. That stair step that caused from wear. As you can see, I got a little bit of heat mark in there from welding. Just lightly knock off so that the last 80% of that ear is at the same height as that first 20% where it never had wear, and you're golden. So don't let stuff like this get really concerned. If you buy a remanufactured one, they either just find one that's not worn, or if they're remanufacturing, this is basically what they do. As long as you just do a nice job, make sure it's clean, it's going to give you good results. So gonna get this up and then throw it in the lathe and get some polishing on that surface to get a nice kind of new bed-in surface for the band. And results of doing this, remember before when I wiggled this drum, it was, it moved like a jump rope. It could sine wave, it can oscillate, it can create side loading on your bushings. Now, it's locked in there. Even though that first 20% was nice and snug previously and that last 80% was loose, now that whole slot is nice and firm. And when you move it in and out, you don't have any gap between that tab and the mating surface. And resurfacing, cleaning up the drum. I chuck the drum in my lathe. I flip the jaws, so I'm grabbing on the non-machined rough surface. And then I'm just gonna spin it, I think like 186 RPM, something kind of slow. I got some WD-40 just as a light machine oil for cutting. And then I took a parallel, drop in my chuck key, and just wrapped my parallel in some 220 grit sandpaper. So then I'll turn that on. I was a little bit hesitant to want to use like a wood block or something because I don't want to put any unnecessary oscillations in the surface of this. I want to keep it flat. So using something that is really flat to resurface it is ideal. I'm not going to go as far as using my actual cutting tool bit to clean that up because that surface is nice. I just want to make a nice, consistent, smooth thing that's like similar to the consistency of a brake rotor to bed in the friction material that's on the band that rides on this. So show you the finished product because you don't need to listen to my VFD whine and mess up your ears. Finished result, you can see that nice surface finish that's left. There's a little bit of grooves that you can feel from your finger, obviously from the sandpaper, the 220 that I used. The WD-40 provides just a nice cutting lubricant that you can wipe off any of the swarf with your shop rag, and it got all that glazing from when the old band kind of burned on here. I didn't really go for a crosshatch pattern. I just spun it about 150 RPM, laid the sandpaper on the parallel like that, and just moved it back and forth a little bit. So that's one drum that is pretty much ready to go. I just got to pull that bearing out, or that bushing in here, and pick up a brake cylinder hone, clean that out, and that one's good to go. Next one, it's not really remanufacturing, but it's, as I covered before, one of those modifications it just makes sense to do. The GM overdrive or fourth gear, which sits on the front of the transmission between the pump and the center support. It has this steel piston. Basically, this half goes into the center support, and then this half pushes against the back of the clutch apply plate. So you can see it's just a steel kind of metal spun part. When you add a third friction, so goes from 4 steels and 2 frictions to 4 steels and 3 frictions. This is now about 80 thousandths too long. So you can buy this part for like 25, 30 bucks or whatever that's already modified, but I have my lathe. Just to show you, this is all the people that sell you the piston do. Even if they do it, they probably just ship like 20 of these to some local machinist. And they do this. So basically, this surface here to the new surface has to be 1.63 inches. This measured 1.713 for me. So I just need to cut off the difference to get this to 1.63 and then use my deburring tool to knock off the burr. And then that's ready to go back together. And sometimes you fail. I was spinning it and this is pretty stringy metal and it caught, and I didn't have it clamped down super tight because I didn't want to screw up the surface, and it chucked the part through the part out of the chuck and basically screwed up all the sealing surfaces. So scrap, and I got to order one. Great. One of the last things as part of the reman procedure is taking out the grooves in the sealing lands on the drum. So you can see you've got, those are the 2 feed holes that eventually do feed the specific clutches. Basically that's where the fluid goes to. And you've got these cast iron sealing ring lands. The cast iron is hard and it will kind of eat into here a little bit. As you can see, this outside ring here, that's basically the sealing land between the reverse apply and the tank, the pan. So the highest pressure, you don't really have a ton of pressure there. If you have a little leakage, it's fine because it's reverse. This first 2 lands matter the most, but you do want to take off any sharp edges because when you install the center support through here, you don't want those cast iron sealing rings nicking or catching on those lands. And these wear because your bushings wear, or you got that jump rope action that we solved. So basically I got a cylinder hone, a brake cylinder hone. I'm gonna put some WD-40 on it and throw it in a drill and just knock those surfaces, the edges, sharp edges off.